everyone, welcome back to my channel. In this video, we are going to derive an expression for radius of curvature in polar form. Let us begin the proof. Let OX be the initial line and P of r comma theta be any point on the polar curve r is equal to f of theta. The distance from O to P is our r, that is radius vector, and the angle XOP is a vectorial angle. Draw a tangent PT to the curve at the point P of r comma theta. Let phi be the angle made by the radius vector OP and the tangent PT, and xi be the angle made by the tangent PT with the initial line OX. From the figure, we can write it as xi, which is equal to theta plus phi. This is obtained by the geometry, that is exterior angle which is equal to sum of the opposite interior angle. This is obtained from the figure. The next step, differentiating the equation with respect to s, we get d psi by ds which is equal to d theta by ds plus d phi by ds. In the next step, we can split the d phi by ds as d phi by d theta into d theta by ds. Hence, we get d psi by ds as d theta by ds plus d phi by d theta into d theta by ds. If we cancel d theta, we obtain the as it is d phi by ds. Hence, we can split d phi by ds as d phi by d theta into d theta by ds. That's our d psi by ds value. In the next step, we can take d theta by ds common. We get d psi by ds value as d theta by ds into 1 plus d phi by d theta. We all know that d psi by ds we can write it as 1 by rho. That is, this is the definition of curvature. The definition of the curvature says the rate of change of xi changes with respect to change in s. That is our curvature value. Hence, in the place of d psi by ds, we can write it as 1 by rho, which is equal to d theta by ds into 1 plus d phi by d theta. This is obtained by the definition of curvature of a curve. 1 by rho is nothing but d psi by ds. And this is our 1 by rho value. If we take the reciprocal of this equation, we get rho value as 1 divided by d theta by ds into 1 plus d phi by d theta. That is our rho value. If we take d theta by ds to the numerator, we get rho as ds by d theta divided by 1 plus d phi by d theta. This is a formula of radius of curvature in polar form, but we have to obtain the value of ds by d theta and 1 plus d phi by d theta. We already know that ds by d theta is nothing but arc length in polar form. We all know that the formula of arc length in polar form is given by ds by d theta, which is equal to square root of r square plus r1 square, where r1 is our dr by d theta, that is derivative of r with respect to theta, we can write it as r1. We already discussed in the previous video, the arc length formula is given by ds by d theta, which is equal to square root of r square plus r1 square. We can substitute ds by d theta easily, but we have to obtain 1 plus d phi by d theta value also. For that, we all know that the angle between radius vector and tangent is given by the formula tan phi, which is equal to r into d theta by dr. Or if we take d theta by dr to the denominator, we get r divided by dr by d theta. Or simply we can take in the place of dr by d theta as r1, hence we get tan phi value as r divided by r1. Differentiating the equation with respect to theta, we get derivative of tan phi with respect to theta, which is equal to derivative of r by r1 with respect to theta. Now differentiating the equation with respect to theta, we get where differentiation of tan phi is secant square phi into, again we have to differentiate this phi with respect to theta, we get d phi by d theta, which is equal to, in the right hand side we have r divided by r1, both are function, hence we have to apply quotient rule over here. We get denominator into derivative of r with respect to theta is dr by d theta, simply we can write it as r1, minus numerator into derivative of r1 with respect to theta is double differentiation of r1. Hence we get r2, where r2 is nothing but d square r by d theta square, divided by denominator whole square, that is r1 square. We all know that from the trigonometric identity, secant square phi can be written as 1 plus tan square phi into d phi by d theta, which is equal to, here r1 into r1 is r1 square minus r into r2 divided by r1 square. In the next step, we can substitute as 1 plus r square by r1 square into d phi by d theta, which is equal to r1 square minus r into r2 divided by r1 square. This is obtained because we all know that tan phi value is r by r1. Substituting tan phi value as r by r1, that is tan square phi here. Hence we get r square by r1 square. Here, in the next step, we have to take the LCM and simplify in the left hand side. That becomes r square plus r1 square divided by r1 whole square into d phi by d theta, which is equal to r1 square minus r into r2 divided by r1 square as it is. Here r1 square gets cancelled in the left hand side and right hand side. Hence we get r square plus r1 square into d phi by d theta, which is equal to r1 square minus r into r2. Or we can take d phi by d theta value as, if we take r square plus r1 square to the right hand side, that becomes r1 square minus r into r2 divided by r square plus r1 square. This is our d phi by d theta. But in the equation, we must obtain 1 plus d phi by d theta. For that, we can add 1 on both the side of the equation. We get 1 plus d phi by d theta, which is equal to 1 plus r1 square minus r into r2 divided by r square plus r1 square. Or we can take the LCM and simplify as r square plus r1 square plus r1 square minus r into r2 divided by r square plus r1 square. That is 1 plus d phi by d theta, which is equal to, here r1 square plus r1 square, we can take it as 2r1 square. Hence in the right hand side we have r square plus 2r1 square minus r into r2 divided by r square plus r1 square. This is our 1 plus d phi by d theta value. Hence equation 1 becomes, what's the equation? Rho, which is equal to ds by d theta divided by 1 plus d phi by d theta. Substituting ds by d theta value as square root of r square plus r1 square divided by, here 1 plus d phi by d theta value as r square plus 2r1 square minus r into r2 divided by r square plus r1 square. If we take r square plus r1 square to the numerator, that becomes rho is equal to r square plus r1 square into, yes, square root of r square plus r1 square, we can write it as r square plus r1 square whole power 1 by 2. Both are same. Divided by r square plus 2r1 square minus r into r2. In the numerator of the equation, we have to observe that this is r square plus r1 square whole power 1 into r square plus r1 square whole power 1 by 2. If the bases are same, hence we can add the powers. That becomes 1 plus 1 by 2 is our 3 by 2. Hence we get rho value as r square plus r1 square whole power 3 by 2 divided by r square plus 2r1 square minus r into r2. So this is a formula of radius of curvature in polar form. This is a very important formula. You must remember this formula, that is rho is equal to r square plus r1 square whole power 3 by 2 divided by r square plus 2r1 square minus r into r2, where r1 is nothing but dr by d theta and r2 is d square r by d theta square. This completes the derivation, that is radius of curvature in polar form. In the next video, we shall discuss how to solve problems using this formula.